Dear students, welcome back to the new chapter Current Electricity, Session 1. In this session, we shall see about sources of direct current, definition of current, symbols used in a circuit diagram, and a simple electric circuit. As usual, whenever you see a diagram, focus on the depiction as you listen to my explanation. Let's move on to the session. Direct current, known as DC, is a current of constant magnitude flowing in one direction. Kinds of cell. Cells are of two kinds, primary cells and secondary cells or accumulators. Primary cells, these cells provide current as a result of irreversible chemical reaction. The cells are discarded after use when the entire chemical energy in them has been converted into electrical energy. Thus, these are use and throw type of cells and cannot be recharged depending upon the material of electrodes and electrolyte. We have different types of primary cells. Example, simple voltaic cell, Lagrange cell, Daniell cell, dry cell, etc. Secondary cells or accumulators. Secondary cells also provide current as a result of a chemical reaction. In these cells, the chemical reaction is reversible and so they can be recharged after use. After taking the electrolyte and electrodes in a vessel, the cell is first charged by connecting it to a direct current source. During charging, electrical energy changes into chemical energy and gets stored in the cell. When a cell is used to send current in a circuit, chemical energy changes into electrical energy. These cells can thus be used for a very long period because they can be recharged again and again. Lead accumulator and nickel ferrous accumulator are of two types of secondary cells commonly used to provide low as well as high current. We use a number of lead accumulator cell as a battery in a car as it is capable of giving high current. Low current rechargeable cells are widely used in toys and mobile phones. These cells are also called storage cell. Now let's see the definition of current. Current is the rate of flow of charge across a cross section normal to the direction of flow of current. If charge q flows through the cross section of a conductor in time t, then current is defined as charge by time. Current is a scalar quantity. In metals or conductors, current flows due to the movement of electrons, while in electrolytes, current flows due to the movement of both the positive and negative ions. An electron carries a negative charge equal to minus E, where E is equal to 1.6 into 10 power minus 19 coulomb, the electronic charge. If n electrons pass through the cross section of a conductor in time t, then the total charge passed is q is equal to n into E, and the current in conductor I is equal to q by t, which can be written as Ne by t. The direction of current. Conventional current is in a direction opposite to the direction of motion of electrons. From relation I is equal to q by t, the unit of current is unit of charge by unit of time. The SI unit of charge is coulomb and SI unit of time is second. So the SI unit of current is coulomb per second, which is called ampere. It is denoted by the symbol A. Thus, 1 ampere is 1 coulomb per 1 second. Thus, current is 1 ampere if the rate of flow of charge is 1 coulomb per second. Since 1 coulomb of charge is carried by 1 by 1.6 into 10 power minus 19, which is equal to 6.25 into 10 power 18 electrons. Therefore, if 1 ampere current flows through a conductor, it means that 6.25 into 10 power 18 electrons pass in 1 second across that cross section of a conductor. Now let's see the symbols used in circuit diagrams. An electric circuit has different electric components connected to a current source. Sources of current. There are two types of current sources: alternating current, which is called as AC source, which, such as mains in our house and AC generator, and two, the direct current source, which, such as a cell or a battery. The purpose of a source of current is to supply electric current, that is, to maintain flow of charge in a circuit. In laboratory, Legland cell, Daniel cell, and lead accumulator are used as direct current sources. A DC source, which is a cell, is represented by two vertical lines of unequal lengths. The longer one is marked plus to represent anode, while the shorter is marked minus to represent cathode. When current is drawn from a cell, it flows from the positive terminal to the negative terminal through the external circuit, and from the negative terminal to the positive terminal inside the cell through its electrolyte, so as to maintain a continuous flow. When a strong current is required, either we join a number of cells together in series to form a battery, or we use a storage cell. Figure represents the symbol for a battery using three cells. An alternating current source is represented by a sine curve within a circle as shown in figure. Now, what is a key? Look at the diagram. It is used to put a current on and off in a circuit. It may be either a switch or tapping key. The figure shows a symbolic representation of these keys when they are open and when they are closed. A key is usually represented by the symbols capital K. In lab, generally we use a plug key shown in figure. When key is open, the circuit is incomplete and is called an open circuit. When the key is closed, current flows through the circuit and is said to be closed. A tapping key is used when current is momentarily needed in the circuit. The key is always connected in the wire connecting the higher potential, that is, the positive terminal of a battery. Resistance wire, resistance box, rheostat, or variable resistance. A resistance wire is generally made of from an alloy called manganese, and it has a fixed resistance depending upon its length and thickness. It is used as a standard resistance. A rheostat is a device by which resistance in a circuit can be varied continuously. It is used to adjust the magnitude of current in a circuit by changing the length of resistance wire included in the circuit. As shown in figure, it consists of an enamel constantan wire wound in the form of a coil over an asbestos pipe fitted in an iron frame and provided with a sliding contact called jockey on a brass rod. It has three terminals A, B, and C, out of which two terminals A and B are at the end of the resistance wire, and the third terminal C is at the end of the brass rod connecting the jockey. The enamel of the coiled wire is removed at the places where jockey touches the wire. The wire between the two terminals A and B provide a fixed resistance equal to the resistance of the entire length of the wire. When rheostat is used as a fixed resistance, R connections are made with terminals A and B as shown in figure. Symbol R is used for a fixed resistance. The main use of a rheostat is as a smoothly varying resistance. For this, connections are made between the terminal C and either of the fixed terminal A or B at the end, as shown in figure. The jockey connected to the middle terminal C can be slided or glided, and by making its contact at different points, variable resistance can be obtained. The current then enters at the positive terminal A or B. It flows in the resistance wire of length up to the jockey and then leaves at the terminal C. In order to adjust the current of a desired value in the circuit, the jockey of the rheostat is slided to obtain desired resistance. Symbol RH is used for a variable resistance. A resistance box is provided with several standard resistance, say 1, 2, 2, 5, 10, 20, 20, 50 ohm connected in series between the two terminals. A resistance of any desired value between 1 ohm on to its maximum value can be used in step of 1 ohm by taking out the plug of that particular resistance from the resistance box. Ammeter. An ammeter is an instrument used to measure the magnitude of current flowing in a circuit. It is joined in series in a circuit so that the entire current of the circuit passes through it. It is symbolically represented by the letter A, enclosed in a circle as shown in the figure. The positive sign marked at one terminal of it indicates that current must enter it through this terminal. Therefore, this terminal is connected to the higher potential terminal of the current source. An ammeter must have a very low resistance so that the resistance of the circuit may not alter when it is joined in the circuit. It has a calibrated dial on which deflection of needle shows the magnitude of current flowing in the circuit. Different kinds of ammeter are required to measure alternating current and direct current. A voltmeter shown in figure is used to measure the potential difference between 2 points of a circuit. It is connected across the 2 points between which potential is to be measured. It is symbolically represented by the letter V enclosed in a circle as shown in figure. The positive sign marked at one terminal of it indicates that current must enter it through this terminal. Therefore, this terminal is connected to the point at high potential. A voltmeter usually has a very high resistance so that it does not draw an appreciable current from the circuit. It has a calibrated dial on which deflection of needle shows the potential difference across the point of circuit in between which the voltmeter is connected. Different kinds of voltmeter are required to measure alternating and direct potential difference. Galvanometer. A galvanometer is used when we want to detect the presence of a very weak current in an electric circuit or to know only the direction of flow of current in a circuit. It does not measure the magnitude of current in a circuit. It is joined in a circuit in series just like an ammeter. It is symbolically represented by the letter G enclosed in a circle as shown in figure. Current can enter or leave through any of its terminals, therefore, no plus or minus signs are marked at its terminals. It has a dial with zero mark at its center. The deflection of needles on it shows the presence of current and the direction of reflection. Direction of deflection indicates the direction of flow of current. Load. An appliance which is connected in a circuit is called a load. It may be just a resistance like a bulb, heater, etc., or a combination of different electrical components. It can be represented by the symbol L as shown in figure. Connecting wires. These are the wires used to connect various electrical components. They are made of highly conducting metal, such as copper or aluminum, so that they are of negligible resistance and do not change the resistance of the circuit. A connecting wire may be thick wire or several fine wires twisted together. Generally, we use thick insulated copper wire as a connecting wire which is represented in a circuit diagram simply by a line. Now let's see a simple electric circuit. In our daily life, we use a torch in which a cell is connected to a bulb. This is the simplest electric circuit which uses only three components, that is cell, bulb and switch. The figure shows a line diagram representing a simple circuit containing a cell, a bulb and switch. As the switch is closed, a current flows through the bulb and the bulb glows. The flow of current stops as the switch is opened. The bulb then ceases to glow. Figure beside illustrates another simple electric circuit in which various components are the cell, key, rheostat, bulb, voltmeter, and ammeter. Here the bulb acts as the load. It is clear that ammeter, cell, key, and rheostat are in series with the bulb, while the voltmeter is connected in parallel across the bulb. To demonstrate the function of various components of circuit shown in figure, first, take out the plug from the key. This makes the circuit incomplete or opens the circuit. The bulb does not glow and both the ammeter and voltmeter read zero since no current flows in the circuit. Now insert the plug in the key. The circuit is completed or closed. The bulb glows and the ammeter reads current in the circuit, while the voltmeter reads potential difference of voltage across the bulb. Then vary the resistance of the circuit by sliding the variable terminal, that is the jockey of the rheostat. The glow of bulb changes as well as the reading of ammeter and voltmeter changes. On decreasing the resistance by sliding the jockey to the left, the glow of bulb increases. The readings of ammeter and voltmeter also correspondingly increase. On increasing the resistance by sliding the jockey to the right, the glow of bulb decreases. Correspondingly, the readings of ammeter and voltmeter also decrease. Students, that brings us to the end of this session. Go through the presentations once more for a better understanding. Bye till we meet again. Take care.